Hi everyone. We're going to start with the next topic today. It's about inequalities. So, just as an introduction, we're going to talk about the number line. Let's take an example where you pick any two number that you want. One of the following is going to be true about it. Either they're going to be equal or one of them is greater and the other is smaller. For example, you picked 7 and 11. Then you have that 7 is less than 11 or 11 is greater than 7. If you pick 12 and 12, then you would say 12 equals 12. So there's only three things that can happen when you pick two numbers. They can be the same number, one can be less, and that it can be more. This is always the case in the reality that we live in. That is, given x and y, one of three things can happen: x equals y, x less than y, or x greater than y. Nothing else is possible or even imaginable. Um, the x equals y case, that's called an equation because it's an equal sign. And the other two cases, x less than y or x greater than y, are called inequalities because they're not equal, they're unequal. For example, 7 less than 5 less than 7, pi less than 4, or negative 5 less than negative 2. I'm just pointing out here that with negative numbers, it looks like 5 is bigger, but negative 5 is smaller, right? Because it's more negative. Now, this fact can be represented on a number line where values increase from left to right. So you have 0 right at the center, and then you go increasing to the right and decreasing to the left. For example, if a number y is to the right of x, then we know y is somewhere here, x is somewhere here, then we know x is less than y. And then if z is to the left of y, I know for sure that z is less than y. So we have certain relationships that can be formed between these numbers based on their position on the number line. Now let's look at how to solve a linear inequality. We are going to draw upon our experience of solving linear equations. So namely, we can add, subtract, multiply, divide to isolate the variable. In this example, I have 2x minus 3 less than equal to 5. I add 3 to get 8, and then I divide both sides. So I get 2x over 2 is less than equal to 8 over 2, or x is less than equal to 4. This on the number line is going to look like number 4 included and everything else to the left. Okay, it can also be sketched in this form. Now there are some properties of linear inequality that you can follow. If you add or subtract a specific number from both sides, the direction is preserved, meaning it's still less than. Now you can verify. For example, 3 is less than 10, and I add 2, and 5 is less than 12. Add 2. And then you can check, I can subtract 2, 1 is less than 9, etc. Now for multiplication division, however, we have to be careful with positive and negative. If it's positive, then we have the same direction. So a times c is less than b times c, a over c is less than b over c. But when it is negative, if c is a negative number, then a times c is greater than bc and a over c is greater than b over c. So when you have negative with a multiply or divide, then the signs flip. Now, why does it flip? If you recall the number line, take the numbers 1 and 3. 1 is less than 3. If you look at the negative version, the negative 1 is greater than negative 3 and not less. Right? That's because on the number line, the values increase in this direction, outward. Right? So they increase in this direction, but they decrease in this direction. So the bigger negative numbers are smaller. Example, 1 minus 2x greater than 10, subtract 1 to get negative x greater than 9, divide by negative 2, and right here the sign is going to flip, right? And that's how it's going to look like on the number line. Some more examples. So I have x plus 3 over 4 greater than equal to x minus 2 over 3 plus 1 half. Now this is different because of fractions. Now recall here, adding fraction is you have to make a common denominator. For example, the common denominator for 3 and 4 is 12. So I multiply by 4 over 4, which is allowed because that's just 1. And I multiply this by 3 over 3, which is also allowed because it's just 1. And I get 7 over 12. So I follow the same strategy. First, I subtract this entire term, x minus 2 over 3. I make the common denominator 12. I file this out, um, end up with x is greater than negative x greater than equal to negative 14, and then I flip the sign and x is less than equal to 14. There's another way to express this result as an interval negative infinity to 14. Remember, the square bracket is used because 14 is included. Or on the number line, you can have a solid dot on 14 and everything less than 14. Let's look at some special examples. X greater than x plus 1. You subtract and you end up with 0 greater than 1. Is that ever true? This is never true, which means there is no solution, or we use this symbol for the set of no solution. This is called the empty set. Okay. Or in terms of description, you can think of it, what are the numbers which are greater than numbers more than itself? It doesn't make sense. There's going to be no solution. Similarly, another case is you can have x is less than x plus 1. That's always true. A number is always less than a number greater than itself. And then if you try to solve it, you end up with 0 less than 1, which is always true. So there's infinitely many solutions, and the solutions are given by negative infinity to infinity. Next video, we're going to look at compound inequality, which is just two inequalities put together.